Hi everybody, if you're watching this video, I'm hoping that you've had some kind of an introduction to linked lists and you may know, for example, how to iterate through a linked list or search for an item in a linked list. If you don't know how to do that yet, then you shouldn't maybe be watching this video. You should go and look at how to do those things first and then come back to this. In this video, we're going to be looking at how to insert a new node at the end of a linked list. So what I mean when I say that is, let's look at this example. Here's my root node, and the next node in the list is 1, so we go to 1, then we go to 4, then we go to 2, then we go to 7, then we go to 3, and that is the end of the list. Now what we're going to be doing is inserting a new node after the current end of the list. Okay? Now the way we're going to do that is in this array example of nodes. Okay, it is a linked list of nodes, but we're implementing this on an array. You can see from what I've just said that the node at index 5, the node at index 6, the node at index 8, and the node at index 9 are not in the list yet. They're not being used in the list. Okay? We went from 0 to 1 to 4 to 2 to 7 to 3, and that's the end. We haven't used 5, 6, 8, or 9. So we're going to say that 5 is the start of the free list. These nodes are available starting at 5. The next one is 6. The next one is 8. And the next one is 9. And that's it. That's the end of the free list. Okay, so that's an important concept for today's tutorial. Now what we're going to do is take this node, put it where the free pointer is. This is the new end of the list, and we need to update this value. This was the old end of the list, but this now needs to say 5. That needs to say 5. Okay? So let's get started and see how to program this in. We're going to be using Python. Now, what I've already done is set up my node class. Again, if this doesn't make sense, you're probably watching this video too soon. You need to go and look at iterating through a linked list or searching for an item in a linked list. I've also set up 10 nodes which match this example. So node 0 is data item 13, next node 1, as per the example. Okay, so these match the example. And then I've pushed all of these into an array because my linked list will be implemented on an array. Now what I'm going to do next is design a function to insert a node at the end of a linked list, not at the beginning of the list and not in the middle of the list. Let's be very clear about that. So I'm going to define a function called insert node, and I'm going to send it a linked list to process, and I'm also going to send it the index of the free pointer. Hopefully that will you'll understand why I'm doing that as we go through the tutorial. So firstly, the logic that I'm going to start with is if this value of the free pointer is less than 0 or the value of the free pointer is greater than 9, because those are the only valid indexes in my example here. So if the free pointer has a value which is outside that range, it means that the list is full. So I'm just going to return -1. Else, we're going to create a new node. I'm just going to put in some random data. Let's say 45. And the new node is going at the end of the list. So its next pointer will be -1, guaranteed. because this is going to be at the end of the list. Now I want to push this new node into the free pointer index. So I could do this. Here is the free pointer index. So linked list at the free pointer index, this element is going to be assigned the new node. So instead of seeing 0 and 6 here, we're going to see 13 and -1. Now, that's a little bit dangerous because I don't want to overwrite that 6 yet. I want that 6 because I'll need it later to update the value of the free pointer. It will become 6. So let's just store that value for now. I'm just going to say new free pointer equals linked list at the current free pointer dot next, which in this example is 6. Okay, so let's just store that value. Then let's overwrite it. And now let's think about how to process the list. Let's set up a pointer. Going to start at the root. So let's just call it current pointer, will be assigned a value of 0. And while current pointer doesn't equal -1, so we're searching for the end of the list, we're going to update the current pointer. Now hopefully you know what I'm doing because you've already studied how to search a linked list or iterate through a linked list. So current pointer equals linked list, current pointer dot next. Okay. So finally, current pointer is going to have a value of -1. That's actually not very useful to us. We need to get this value of 3 because this is the index of the last node in the list. And we need to do some stuff here. So to get that 3, we need to get it from the previous node. There it is. That's the 3 that we're looking for. Current pointer equals 3. Does that equal -1? No. So we jump to the next node, and the current pointer is updated to -1. We know that we've reached the end of the list, but we don't know the index of that node. So what we can do here is just set up this. And let's have a look and see what's going on here. So current pointer is 0. Previous pointer equals current pointer. So previous pointer is 0. Current pointer becomes 1. Previous pointer equals current pointer. So previous pointer is 1. Current pointer becomes 4. Previous pointer becomes current pointer. So previous pointer becomes 4, and current pointer becomes 2. Previous pointer becomes 2, current pointer becomes 7. Previous pointer becomes 3, current pointer becomes -1. We've reached the end of the list, but we know where we are because we saved that value. So that's what that logic there is doing as we iterate through the linked list. Okay? So now that we have that value, we can do a few funky things. We need to update that to have this index, free pointer. Okay? So linked list, previous pointer, dot next is assigned the value of the free pointer, which in this case is 5. Does that make sense? Linked list previous pointer, which is linked list 3, which is here, linked list 3 dot next becomes 5. That's what we're looking to do. Okay? And remember, we've already put our new node into that position. Sorry, I've put free pointer there. I didn't call it free pointer, did I? It should be free p. Sorry guys, that's confusing. Free p is the variable that I'm using to store the free pointer, the current free pointer. So we've put the node into place. We've updated this. All we have to do now is update the free pointer so that it becomes this value. Do you remember? I've already stored that. I stored it here. This is the value 6. So let's now update free p. And that's what I'm going to return. Okay. Now to see this work, after we insert, I want to create another while loop just to iterate through the linked list and see if it's doing what we want it to do. So let's just display the contents of the list. We're just going to set up another pointer, set it to 0, while pointer doesn't equal -1. Pointer, let's print out linked list pointer dot data item. Did I call it data item? I called it just data. And then update the pointer. Pointer equals linked list. It's a capital L, isn't it? Linked list pointer dot next. So this little loop here is just displaying the contents after we insert a node. And then I'm going to return the free pointer back to the calling program. Okay, so let's have a go at this. This is completely mad, isn't it? Let's call the insert node function now in a main program. Insert node, and we're going to send it this list. That's the first parameter, isn't it? The first parameter is the list, and the next is the free pointer. Remember, as we get started, free pointer is 5. So I'm going to feed that manually into the function. Oh, and we're returning a value, aren't we? So I'm going to say free pointer, the new free pointer. Let's call it NFP. New free pointer is this. And let's run this and see if it works. Oh, new free pointer is not defined. New free pointer. Let's run it again. Oh, 13, then 15, then it jumps to 4, which is 17, then it jumps to 2, which is 21, then it goes to 7, which is 23, then it goes to 3, which is 29, and then it jumps to that new one, which was 45. Do you remember? Now I've managed to grab the next free pointer, so let's do it again. And send it the free pointer that we just grabbed. And let's run it again. It starts again, and there are two 45s. I think it works.